Here's the first example from your note packets. We're going to complete the square for this example and then find the x-intercepts. The first thing we want to do is rewrite the equation with the first two terms grouped, leave a big space here, and put the negative 11 off to the side, also with a big space before you write 0. Then what we have to do is figure out what is the number that will go here so that this polynomial will factor as the same binomial twice, basically be a perfect square. The way we're going to find that is we're going to take the coefficient of the x term, which is 10, technically negative 10, but we can just use 10. Divide it in half, always divide it in half, and then square it. So half of 10 is 5, 5 squared is 25. 25 is the perfect number. I'm going to add it here, but because I don't want to change the equation, I'm also going to subtract it over here. So now I have actually the same equation, it just looks a little bit different. If I've done my work right, this equation should now factor as two binomials that are exactly the same. So it turns out that the two numbers that multiply to give you 25 but add up to negative 10 are negative 5 and negative 5. So we can just write it as x minus 5 squared. That's the square in completing the square. And then negative 11 minus 25 is negative 36, and it's equal to 0, and I've completed the square. This is now, it started in general form, and now I've put it in vertex form, which is another way of saying I've completed the square. But we're not done. We need to solve for the x-intercepts. So we're going to un-PEMDAS and dismantle this equation piece by piece, starting by adding 36 to both sides. So now x minus 5 squared is equal to 36. To unsquare the square, we're going to take the square root of both sides, and we know that as soon as we put in a square root where there wasn't one before, we're going to get two answers. X minus 5 might be equal to 6, the square root of 36 that you always think of, but x minus 5 might be equal to negative 6, and this is how we're going to get two answers. When I add 5 to both sides here, I find that one of the x-intercepts is 11, and when I add 5 to both sides here, I find out that the other x-intercept is negative 1. So this function has two answers, two x-intercepts, one 11 and one negative 1, and I am done with this problem.